Welcome to my presentation. In this presentation, we shall try to solve system of linear equations with an application example problem. So let us say that you purchased two types of nuts. One type selling for $8 per pound, and the second type selling for $10 per pound. The nuts are to be mixed to provide 100 pounds of a mixture selling for $9.50 per pound. How much of each type of nuts should be used to make 100 pounds of the mixture? So to solve these types of application problems, we're going to use system of linear equations to solve them, and then in here we will use matrices to solve the system of linear equations. So from the problem, what we see is the following things. Step number one. In here we'll say let X be the amount of nuts which are sold at $8 Let X be the amount. Let me write this thing down. Let X be the amount of $8 nuts, and let Y be the amount of $10 nuts. Okay, since the mixture must be 100 pounds, we can write a linear equation based off this information. Therefore, we can say X plus Y is going to be equal to 100 pounds. So this is our equation number one. In step two, we will write the second equation. From the question, the information we can obtain is this. The $8 nuts, this $8 of type X nuts, let me write this, $8 of type X nuts plus $10 of type Y nuts should equal to, we want to sell the mixture at $9.50, but of 100 pounds. We want to make 100 pounds of that mixture. So this is our second equation. So with this information, we can just come back and then write this as a linear equation as 8x plus 10y is equal to 9.5 times 100 is equal to 950. This is our second equation. So we have a system of linear equations from this particular for this particular problem. So the system of linear equations are as follows. X plus y, let me write this again. X plus y is equal to 100. This is equation number one. And 8x plus 10y is equal to 950. These are our system of linear equations, and the two unknowns here are x and y. The two variables here are x and y, and x represents the type of X nuts, and Y represents the type of Y nuts. So with this information, we can use matrices from this point on to be able to solve this system of linear equations. In here, we're going to now, let me write this as step number three. We can write the augmented matrix based on the system of linear equations, and then to write the augmented matrix, we're going to pick up the coefficient terms for x and y in equations 1 and 2 and write it out in the matrix format. So the coefficient of x in the first equation is 1, the coefficient of y in the first equation is 1, the constant term is 100. And in the second equation, the coefficient of x is 8, the coefficient of y is 10, and the constant number is 950. So this is our equation. This is our augmented matrix. We want our goal, let me write this as step number 4, and then we will solve this augmented matrix. Our goal is to create an augmented matrix or obtain an augmented matrix by using the row operations and then write it out in this manner: 1a, b, 0, 1, c. We want a augmented matrix in this format, and then in here we want the diagonals to be equal to 1, and the value below the diagonals should be the elements below the diagonal should be equal to 0. So we will go ahead and then now solve this system, this augmented matrix. We'll call that as step number 5. Since we already have 1 in the first row, first column, we want to make this location equal to 0. So to make that location equal to 0, we're going to perform the row operations, and the way to do that is as follows. We have 1, 1, 100, and then the second row, the new row, is going to be equal to minus 8 row 1 plus row 2. So minus 8 times 1 plus 8, so negative 8 plus 8 is going to be equal to 0. Negative 8 times 1 plus 10. 8 plus 10 is going to be equal to 2. And then we have negative 8 times 100 plus 950. So this is going to be negative 800 plus 950, and that is going to be equal to 150. Negative 800 plus 950 is going to be equal to positive 150. So this is what we've arrived, and therefore to be able to write it in a clean manner, this is how it's going to look like. This one is going to look like this: 1, 1, 100, and then 0, 2, 150. So this is what we have, and we want to now be able to see where we are on the finish line. We want a 1 in the first row, first column. We want a 0 here, we got that. We want a 1 in this location. Therefore we're going to continue our row operations and then see how we can arrive at that, how we can achieve that. So in here now we're going to perform the row operations again. 1, 1, 100, that is the first row, there is no change in there. And in the second row, we're going to say the second row, the new row, is going to be equal to the existing row divided by 2. We're going to divide by 2 throughout. 0 divided by 2 is going to be equal to 0. 2 divided by 2 is going to be equal to 1. And then 150 divided by 2 is going to be equal to 75. And therefore, we have now arrived at a augmented matrix which is going to give us the solution. So let me write this in a clean manner: 1, 1, 100, and then 0, 1, 75. This is, let me write this as a clean 0. This is a 0 here, 100. Therefore this is our solution augmented matrix, and as we can see, we have achieved 1s along the diagonal and we have achieved 0 below the diagonal. And therefore we can read the solution from this point on, and then the solution is as follows. From here y equals to 75. The value of let us write the system of linear equations from this final augmented matrix. X plus y is equal to 100, and the value of y is equal to 75, and that is one of our answers. And if we were to go back and then back substitute the value of y into the first equation, we can get the value of x, and then the value of x plus 75 is equal to 100. Therefore we can find the value of x as follows: x equals to 100 minus 75, which is equal to 25. The value of x equals to 25. Therefore the solution here is x equals to 25 and y equals to 75. This means what this thing is telling us is that you will need 25 pounds. This means we need 25 pounds of $8 nuts, and we will need 75 pounds of $10 nuts to be able to make 100 pounds, of nuts selling at $9.50 per pound. So that's the way we want to be able to tie it back into the given problem. So this is our solution. This is where we want to leave it. And in here we have solved is an application problem using a system of linear equations, using matrices to be able to arrive at the answer, and we were able to then confirm that the two values which we have obtained checks back into the given problem as well. In my next presentation, we should look at some more application related problems to see how we can solve system of linear equations using matrices.